For the past 100 years, our cities have been built on a fundamental, unshakable logic. To go faster, you must go underground. And to handle more people, you must build more tunnels. Whether it's the London Underground, the New York subway, or the Paris metro, the blueprint has been the same. We dig deep. We pour massive amounts of concrete. We lay heavy steel tracks, and we battle the crushing physics of friction and gravity. But what if we've been looking at the problem the wrong way? What if the solution to urban congestion isn't beneath our feet, but above our heads? In a world where urban centers are reaching a breaking point, where traffic isn't just a nuisance, but a multi-billion-dollar drain on the global economy, China has quietly begun a radical experiment. It looks like something pulled from a science fiction blockbuster. It is a train that doesn't roll on wheels. It doesn't consume electricity to stay afloat, and it glides through the air in total, eerie silence. This is the Red Rail, the world's first permanent magnet-suspended monorail. But this isn't just a gimmick. It is the flagship of a massive, coordinated effort to reinvent how humanity moves. Today, on The Global Build, we are going to strip back the layer of shiny marketing to explore the physics, the economics, and the sheer audacity of China's floating revolution. In Part 1, the physics of zero power. To understand why this is a revolutionary leap, we have to talk about magnets. We are all familiar with Maglev, magnetic levitation technology. We've seen the impressive videos of trains in Japan or the Shanghai Trans Rapid, where electromagnets lift the train off the track to eliminate friction. But there is a catch. Those trains are energy hungry. To keep a heavy train levitated, you need a constant, massive flow of electricity to generate a magnetic field. If the power cuts, the system fails. The Red Rail, located in the Jiangxi province, changes the fundamental equation. It uses what engineers call permanent magnets. Think of a permanent magnet like the fridge magnet holding your grocery list. It doesn't need a power outlet to stay stuck to the metal. It is inherently magnetic. By utilizing the natural, intense repulsion force between high-strength rare earth magnets on the track and the train, the Red Rail remains suspended 10 meters above the ground, effectively locked in a state of levitation. Because it relies on the magnetic properties of the materials themselves rather than a constant surge of electricity, the energy cost to keep this train floating is, for all intents and purposes, zero. It is a passive system. Even if the entire power grid of the city were to fail, the train wouldn't drop. It would remain floating in its magnetic cradle. So this technology is the culmination of decades of research, but it is also a geopolitical masterstroke. China currently controls over 80% of the world's rare earth elements. These elements are the vitamins of modern technology, essential for everything from smartphone screens to electric car motors, and specifically for these powerful magnets. By mastering this supply chain, China isn't just building a train. They are building an infrastructure monopoly that the rest of the world is currently struggling to compete with. Part 2. The urban advantage. Reimagining construction. Now, you might be asking, why go through all this trouble? Why not just build a standard subway? The answer is found in the brutal economics of urban construction. If you live in a city like New York or London, you know the horror stories of transit expansion. Projects like the 2nd Avenue subway or the Crossrail project in London have cost billions of dollars, taken decades to complete, and caused years of agonizing street-level disruption. When you build underground, you are fighting a war against the city itself. You have to move massive sewer lines, navigate electrical grids, avoid the foundations of century-old buildings, and deal with unstable soil. Every meter you dig is a gamble. The Sky Train, or the Red Rail, approaches this entirely differently. It is essentially plug-and-play infrastructure. The pillars that support the tracks occupy a tiny footprint on the sidewalk, no larger than a streetlight. The tracks themselves are modular, meaning they can be manufactured in a factory and assembled on site like a giant high-tech Lego set. China claims that the construction cost of the SkyTrain is roughly 1/10 of an underground metro. But the real magic is in the geometry of the suspension. Though because the train hangs below the track, it is inherently stable. It can handle much steeper inclines and much tighter, sharper turns than a train sitting on top of a rail. In dense, mountainous cities like Chongqing, where traditional trains struggle to traverse the rugged landscape, the SkyTrain can weave through skyscrapers and over rivers with surgical precision. It solves the last mile problem. It's the ultimate solution for cities that were built before the modern era, where there is simply no space left on the ground and no money left to dig deep tunnels. Part 3. The 600 km/h high-speed beast. However, the SkyTrain is just the appetizer. While that technology conquers the inner-city congestion, China is currently developing a monster designed for the long haul. In the coastal city of Qingdao, they have unveiled a prototype that looks less like a train and more like a fighter jet. This is the 600 km/h high-speed Maglev. To put that speed in perspective, it is nearly 75% of the cruising speed of a commercial airliner. When you are traveling at 600 km/h, you are covering 10 miles every single minute. This fills the critical speed gap in modern transportation. We have high-speed rail, which typically caps out around 350 km/h, and we have commercial aviation, which cruises at around 800 to 900. But short-haul flights are inherently inefficient. You have to travel to the airport, go through security, wait at the gate, board, taxi, take off, climb, descend, taxi, and then get to your final destination. A 600 km/h Maglev effectively kills the domestic short-haul airline industry. Imagine a trip from Beijing to Shanghai, one of the busiest routes on the planet. By plane, it's a 3-hour flight, but once you factor in airport security and transit, it is a 5-hour ordeal. This Maglev could do the same trip in 2.5 hours, station to station. No runways, no flight delays, and significantly lower carbon emissions per passenger. It is a machine designed to reshape the map of the country, shrinking travel times to a degree that was previously impossible. Part 4. The critics and the geopolitical gamble. But we have to be balanced. Building the future is expensive, and it is fraught with risk. The history of megaprojects is littered with the corpses of ambitious ideas that went nowhere. Critics and economists point to several major challenges. First, there is the issue of integration. It is one thing to build a test track. It is another thing entirely to integrate a high-speed Maglev system into existing rail networks, stations, and cities that were built for 19th century trains. The cost of upgrading the supporting infrastructure, the electricity grids, the signaling, the station terminals, is astronomical. There is also the debt argument. Many analysts have argued that China's rapid infrastructure expansion is fueled by massive debt, and that these Maglev projects are prestige projects. They are meant to show the world that China is the technological hegemon, even if the projects themselves never turn a profit. Some skeptics compare these Maglev lines to the ghost cities of China. Massive developments that look impressive on paper, but lack the ridership to justify the investment. Furthermore, there are concerns about the environmental and health impacts. We're talking about trains moving at 600 km/h through residential areas. The noise pollution and the electromagnetic fields generated by these systems are subjects of intense study. Can you live next to a train that hums by at speeds faster than a race car? That is a question that city planners are only just beginning to answer. But perhaps the most significant challenge is the geopolitical one. We are seeing a new kind of Maglev diplomacy. As China perfects this technology, they are looking to export it. They want their standards, their tracks, and their rare earth supply chains to become the global standard for 21st century transport. This puts the West, which is currently mired in aging rail networks and regulatory gridlock, in a difficult position. Are we watching a repeat of the 5G race? Is this another instance where China sets the stage for the future, while the rest of the world is left playing catch-up? As we look toward the horizon of 2030, one thing is abundantly clear. The era of the steel wheel on steel rail, a technology that has defined humanity since the Industrial Revolution, is reaching its physical limit. To go faster, to go cheaper, and to go greener, we eventually have to let go of the ground. The SkyTrain and the 600 km/h Maglev are not just fancy trains. They are a bold statement of intent. They represent a fundamental shift in our relationship with gravity and friction. Whether these projects become the global standard or remain a uniquely Chinese specialty, they have effectively forced the world to rethink what is possible. The engineering challenges are massive. The economic risks are real. But the vision? The vision is undeniable. We are moving toward a world where the commute is silent, the travel is frictionless, and the city is no longer a cage. So here is the question for you. Would you trust your life to a magnet 30 feet in the air? Or do you think the tried and true tunnels of the past are still the only safe way forward? Let us know your thoughts in the comments below. If you enjoyed this deep dive into the engineering that is quietly reshaping our planet, make sure to hit that like button. And don't forget to subscribe to The Global Build. We are documenting the rise of the megaprojects that will define the next century. And we don't want you to miss the next one. We'll see you at the next project.